going to talk about AI Leap. It's a Catalyst presentation in panel format. First of all, introducing the champions. So we had AT&T, BT and Orange as the project champions, which was great because we can use real network data to do the proof points bit around AI Leap. And we've got a selection of participant companies, Federos, Arago, Galileo Software and Wavelength. And we've got a mixture on the panel today. Just to explain the name, so we did a bit of brainstorming on the name. There's a lot of machine learning built in. Machine learning is to support root cause analysis based on event analytics as the data source. We're looking to spot patterns, irregularities and that type of thing. From those patterns, we're going to introduce automation and talk through that. And finally, taking advantage of predictive approaches to trend forward into the future and identify network problems. Looking at the use case summary, and this is driven directly by input from our champions. This is real network problems they were trying to solve. The first one was related to inverted detection and reconciliation. So one of the biggest challenges in a lot of systems is if you don't have the right topology, whether it's a service or a configuration inventory type topology, then you can miss very valuable information. So by taking data, you can infer where the topology is incorrect and then take a proactive action to fix it. And then there's some intelligence, some AI function in the approaches you take to automating the fixes that are applied back to the network. The second use case we were looking at was trying to detect when anomalies are occurring in particular environments, particularly with the digital services, to come up with performance metrics and to trend forward in time and then identify that and apply fixes. So we're going to move to a panel format. So first of all, I'll introduce the panel. I'll start with myself. My name's Steve Bowker. I work for Wavelength Communications and we do a lot of work around the 5G. So we did a bit of an extension into 5G at the end of that. Excuse me? We've just lost the screen. Oh, let's come back. Sorry. It's okay. Jose, do you want to introduce yourself?
Hello, everyone. I'm Jose Dominguez. I'm Chief Assurance Architect at BT and the lead champion on this Catalyst.
Hello, I'm Torsten Buscher. I work for Arago. I'm the Director of Global Customer Services and Delivery.
And good afternoon. Tim Hayward. I'm the Head of Product Management and Marketing for Federos.
Okay, and I've already mentioned at the beginning we took a real set of sample data, well, real data from one of our champions. So if you can talk about the challenges that we're trying to address with the Catalyst. It'd be great if you start, Jose.
Okay, yes. So we communication service providers, I think, invariably are all on a journey towards automation. And I like to think as automation as a three-dimensional problem. The first dimension is data quality. Without accurate data, bad things can happen when you automate. Trust me on this one. The second dimension is the amount of data one needs to process. The more data you have, the better the automation outcomes. But of course, the more data you have, the more computing power, the better the tools and technologies you need to process that data. And finally, the third dimension, which is a largely forgotten problem, is what can you automate and how you optimize that automation process. Because it's very easy to automate something and just do the wrong thing over and over again, or a suboptimal process. And if you're going to repeat it over and over again, you want to spend some time thinking on how that automation is going to work.
Okay, thanks. That's very useful. Tim, do you want to chip in there?
Yeah, just picking up from what Jose was saying then. Yeah, data quality, key to it. I think I'll do the normal version, rubbish in, rubbish out. I think we all know that. And if your output from your process is triggering automation, you better be certain of your data and what you're doing before you trigger that automation. So certainty, we built in some algorithms and some logic in the Catalyst to make sure, as certain as we could, i.e. we saw something 3 times before we then triggered an automation and sent that automation to Arago. So that's the sort of front end. And then on the back end, we also see a lot of validation steps which are missed off. You fire the automation, but you actually don't go back and check that that automation has actually worked. So this fire and forget concept, which is not wise.
Torsten, do you want to chip in from the business process or workflow angle? What are the challenges or that you address?
Yeah, so what the Hero Engine provides for this project is basically the ability to automate. It does that by recording your best expert's knowledge and then making that knowledge executable and repeatable for every time you have an event that occurs. By making it repeatable, it acts as a multiplier. So whenever you have a knowledge requirement, let's say you have a large event inside your network where you need 1,000 eyes and 1,000 arms, with an automation engine like this, with an intelligent automation solution, you have that.
Yeah. And I guess where you have, for instance, it's a common problem in mobile networks where you get alarm floods or big events happening at the same time. If automation can do the heavy lifting and that side of things, that can also help a lot and stuff. So just digging into the automation aspect a little bit further. So again, coming back to our champion here. So what would you see the benefits of automation can bring in addition?
Yeah, so a lot of the times people think of automation as a cost-saving measure. It isn't actually about cost savings. It's primarily about two things. One is automation allows you to, in the new world, allows you to deliver services. Without automation, those services simply cannot be delivered. You just do not have the people to deliver new services. So automation comes as the first step towards delivering a service, is how you're going to automate it. The second aspect is an aspect of repeatability. With automation, you can repeat something over and over again with the same quality, the same quality, same precision, the same outcome. And that is so fundamental. People expect, if they order a service, they expect to get the service, and if they order it again, they expect to get the same service.
Brilliant. So Tim, do you want to chip in again and add something to that?
Yeah. I'm not sure we've got any choice anymore. I think if you've attended lots of the sessions over the last couple of days, I don't think it's optional that we can use machine learning and AI techniques and automation. There's no choice anymore. There's too much data. There's too many complex environments. So we have to use these tools and techniques, and we have to use the data, which is the valuable asset that we've all got. There's a lot of it. We just need to use it intelligently to then drive automation. And that's the only way, unfortunately, we're going to survive. So.
And I guess correlating between the data sources is also quite important.
Yeah, absolutely. So as Jose said at the start, having multiple data sources, whether it's just fault events, performance metrics, topology information, which is what we were dealing with in this catalyst, trying to improve the quality of that data automatically, which is what we managed to do with this project, is absolutely critical. And I think we need to continue to innovate in those areas, because nobody has got the resources or the time or the effort or the investment to sit there trying to manually manage this data and improve the quality of it. So.
I guess if we can bring a business aspect into it as well, Torsten, you told us about something a bit earlier that's useful sharing.
So what we're doing in this catalyst and what we've done with our product is basically improving inventories. That was our first use case. We've shown that with 3 months of data, we've been able to get an inventory accuracy improvement of 2 to 3%. We've seen in some of our service provider clients that if we follow that model through, they've gained $2 to $3 million a year in revenue by simply having a more accurate inventory and knowing what exactly they need to build their clients for managing. Because the real world is clients add devices to the network, they manage it without even knowing about it, they respond to alerts from it. Now we've basically stretched this into business process automation. We discover the device, we update the systems of record, it becomes a billable item and improves the bottom line.
Okay, very good.
I think without that data, then again, we showed it in the presentation, so come and visit us downstairs, that if you don't have accurate data, then you will waste resources investigating probably spurious root causes. So you may have two issues that may or may not be linked. If you can't link them, then you're going to have two people investigating the same root cause, but you don't know it's the same root cause until you put this data together. So.
And yeah, it was quite interesting. It was a good graphic showing how the root cause tree goes a lot deeper and it gets very precise, so speeding things up. Yeah.
Yep.
So, Jose, do you want to just talk a little bit more about the data and that 2 to 3% and provide background behind that? Because that's real.
Yes. So on this catalyst, we wanted to use real-world data. We wanted to really explore the technologies and the outcomes we could get from it. It was an interesting ploy because I didn't know what we were going to expect and what we were going to find. So there were some nervous moments. But anyway, like in all catalysts, there's a bit of edge. So we started with about 48,000 connections, topology connections. And we started with about 3 months of event data, which was 150,000 events or so. And then we gave it to our data scientists and the good folks at Fedros. We asked them to see if they could use that event data to clean inventory. It's not quite obvious, but in fact, there's a lot of hidden meaning in that event data that can be used to perhaps understand that there were issues with your inventory. And so they set off on this journey, and eventually what we ended up is finding we could clean up to about 2 to 3% of, depending on how you look at it, 2 to 3% of inventory. Our inventory is already on the side of quite accurate, okay? But because there are some manual processes involved in that inventory, then that means that eventually things don't quite align. So to achieve a 2 to 3% is to me, I was very impressed actually. I wasn't expecting such clear-cut results. In fact, I think if we pushed from 3 months of event data into 6 months and in 9 months, then there would be even a higher multiplier, not 2 to 3%, but a higher number.
Okay, thanks for that. That's very useful. And I guess, Tim, if you talk about how the machine learning can help improve accuracy to add to that.
Yeah, absolutely. So the data that Jose and VT provided very kindly was obfuscated to an extent. So very simplistically, we took events that didn't seem to be linked that happened in pretty much the same time frame within a 5-minute area, within a 5-minute time period. We then, next step, which we'll come on to hopefully with phase 2, is to take same location data as well. The chances are that if these events happen multiple times at roughly the same time in the same area, there's probably a linkage there. So that's what we were building on to then, as I say, 3 times. This event had to have happened 3 times. And then we've got the certainty, which we can then trigger the automations. So we continually improve and feed back in a closed loop way to improve the data within the topology and the inventory systems. So it's using machine learning, it's using the data to improve data. So again, back to the earlier point, use it, exploit the data. It's there, you just have to do it intelligently.
Great. Okay, well, we've kind of talked about the outcomes, and there's also other things we contributed or looked at from a TM Forum perspective. I don't know if you want to dig into that.
And I just wanted to make a further point on the outcomes. The reason why it's so fundamental to have accurate inventory data is because if you're trying to provide an assurance function on your network, if you have data that is not accurate, you end up wasting resources, not twice as many resources because you're assuring to things that aren't connected, but actually a higher multiplier because you start a repair function on one device, a repair function on another, and by the time you actually go down the line, you've multiplied the number of resources involved in that, and then eventually they converge to the same fault. So it's really critical to have that accurate inventory. An aspect we wanted to cover in this catalyst that's very dear to us is the AI management standards, and that is something that that is something that BT in Rob Clarkson present here are co-leading. So the idea is that with AI and multiple AI systems eventually being deployed, you need to understand fundamentally these three aspects about an AI system as we see it. First of all, can you audit what that AI is doing? The second one is, can you control that? Can you implement a series of policies on that AI so that you can stop it if it goes wrong? This is very important again. And then what's been called a snapshot, which I like to think of it as a birth certificate. When you create an AI model, can you actually assign some sort of identifier to it so that you can version control it, you can evolve it, you can understand where it came from, what data resulted from it.
Okay, great. And Torsten, do you want to talk a bit about the workflow aspects?
Yeah, so I think the hero product that I'm talking about that provides the automation for this catalyst answers yes to all three of these questions, right? If you teach that automation to apply a policy, you can be assured that that policy will always be applied because it'll not forget like a human being might forget. If you ask it to record record every step, so you have an audit trail, an accurate audit trail, it can do that. It can talk to multiple systems of record and make sure that you have the right information for the right people at any given point in time at your fingertips, flawless and end-to-end every time. Again, not something that human beings are particularly well suited to doing. And lastly, does it have a fingerprint or DNA? Do we know where the knowledge comes from? Yes, because we are actually capturing knowledge from human beings. We're capturing that what the best engineers know, and we're institutionalizing that for our organizations. So in the end, we also fight knowledge drain. If somebody chooses to leave the organization, their knowledge stays with us because we institutionalized it. We know where it came from, we know what it does, and how it's applicable to our targets.
Oh, very good. And Tim, there was other things we worked on as well. Do you just want to touch on the...
Yeah, so we also looked at implementing the AI data model. So this is, the objective is to have a common data model for all AI applications. So a lot more reusable, a lot more easy to integrate for third parties using AI. We fed back a lot of good findings to the TM forum itself, which is one part of an important part of the catalyst. It was quite a complex data model for what we were trying to do with it. So we fed back some of the documentation aspects and some of the complexity aspects. A really good investigation into use of that.
Yeah. And that's looking at the future as well. We've spent a bit of time looking at how it could be applied to 5G. So as 5G rolls out, particularly the earlier versions of 5G, which will be in a non-standalone form, so using the evolved packet 4G core, but with the new radio side. And then the fact that the 5G infrastructure will always have to interwork with legacy. It can be legacy transport, it could be legacy different areas. And also how as 5G evolves into the full-blown standalone deployment where network slicing becomes possible, the AI leap principles can be applied around the orchestrators in the network. So you can still do anomaly detection, you can still detect when the orchestrators are going out of their bounds on policies, out of their design, and also provide the feedback because the standardization hasn't yet automated how it sets the thresholds. I'd be interested in just getting any comments from the panel as well on how you see it going in future and how it can be applied to 5G. So, Jude.
Yeah, from a 5G perspective, we are, and if you think about it, what is going to happen is you're going to have maybe a 10 to 100 times more data reaching our systems. Without automation, without systems that can deal with that complexity, it is just going to be impossible to deploy 5G to the quality we need to, made more difficult by the fact that we have this wacky stuff like bringing all these slices and stuff like that, which poses yet another challenge to our systems.
Yeah, and I guess things like, the great thing about 5G, it provides a diversity of all the different services, lots of business models, so there's things like network slices as a service. These types of things can be introduced as well. The management aspects of that get more complex. They can be very simple slices or they can be very complex slices. So that's where it starts to become very important, the evolution and the growth towards 5G. You look like you were about to chip in something there, Tim.
No, I was just exactly going to say that the complexity of it and managing quality of service, is going to be a real challenge. So this sort of technology, these sort of solutions, absolutely no question that we need to use them. Yeah.
Great. And for anyone who wants to actually see the full presentation, because we've kind of only done 3 out of the 45 slides we have, and there's a whole load of material that's been done. We're downstairs on level 2, towards the end in the AI. There's an AI section where there's a few catalysts that are very focused around AI, just past the attendees' lunch area. So thank you for attending. It's been a pleasure to talk to you. If you've got any questions on the floor, we can ask as well, I guess. No questions, I don't think. Okay, I thought I'd give them the opportunity. Thank you very much.
Thank you.
Thank you.
Okay.